All right, so lesson 4.8, this review, is talking about solving equations and specifically focused on solving quadratic equations, but the way you solve this could be the same for whether it's a quadratic or a cubic, meaning remember if the largest exponent is a 2, it's a quadratic. Right? But if the largest exponent was a 3 or a 4, you still would want to look to see if you could solve it the same way. So first thing that we do is we want to get everything over to one side and put the other side equal to 0, which in this first one, it's already done that way for us. But if it wasn't, we'd want to move everything over, right? And so then we look at that and we say, all right, is there a greatest common factor that can come out of both of those terms? And there is. It looks like x can come out. All right, we'll factor out, and that will leave us with x plus 6. And then remember, this is an equation, so we'll make sure you set it equal to 0 here. And then we will set both parts equal to 0 and solve those two factors, right? So we're setting each factor equal to 0. So on this first one, x equals 0, well, there's nothing there to solve for. That's going to be one of our answers. But then we put x plus 6 equals 0. And if we solve this one, we'll get x equals negative 6. So those are our two answers on it, 0 and negative 6. Okay? On the second example, same kind of thing. Make sure that when you're trying to solve a quadratic, get everything over to one side of the equal sign and the other side equal to 0. Okay? And then we're going to try and, again, factor it from here. So if I try and factor this, right, since the leading coefficient's 1, I can go straight to these parentheses. All right, so what times what is x squared? X times x. What times what is negative 12? That adds to be negative 11. Right, so if you do like 1 times 12, 2 times 6, 3 times 4, right? And then when you look at this, right, the only way to get to that negative 11 in the middle is to choose 1 and 12, where 12 is negative. Right, so x plus 1 and x minus 12. And then set both of those parts equal to 0, right? Each factor needs to be set equal to 0 and solve for x. So we'll subtract the 1 over. X equals negative 1. And then we'll add the 12 over. And x is positive 12. Right, so there are our two solutions. And when we start off with a quadratic, right, meaning that there is our highest exponent is a 2, right, then we expect to end up with two solutions. Okay, if it was a cubic, we expect to end up with 3 solutions. Right? All right, so let's look at the two-story problems now. So this first one, let's read through it. A cryptographer needs to arrange 60 numbers in a rectangular array. All right, so it's talking about kind of like if you were in Excel or something like that, right? An array, has columns and rows, right, and so on, okay? And they need 60 of them here. I don't have 60 of them, but that's what they need, okay? And let's see. So in a rectangular array in which the number of columns is 2 more than twice the number of rows, find the number of rows and the number of columns. All right, so this one sentence right here, right? So number of columns is 2 more than twice the number of rows. Well, we don't know how many rows we have, so I'm going to call my number of rows, right? Give it a variable, and I'll call that r. And if I call that r, then I can figure out what to name my number of columns because I know that there's a relation between them, right? The number of columns is 2 more than twice the number of rows. So twice the number of rows plus 2. All right, twice means 2 times, so 2 times r plus 2. All right, so now from here might seem a little bit tricky, but think about if you were trying to find the area of this rectangle, right, you would do the length times the width. And in this case, we're trying to do the number of rows, right, times the number of columns so that we can end up with 60. Right, so I'm going to write this over here. It might be a little bit easier. So I want to do the number of rows, right, times the number of columns. And I know that that has to equal 60 because that's what they said in here, right? We want it to end up being 60. Well, my rows is just r, and my columns I'm calling 2r plus 2. All right, so I have r times 2r plus 2 equals 60. All right, now let's distribute that r through because we're trying to solve this for r now. So 2r squared plus 2r equals 60. All right, and remember we're solving a quadratic, so we want to get everything on one side, put the other side equal to 0. So if I subtract that 60 over, I'll have 2r squared plus 2r minus 60 equals 0. And now I need to use my skills with factoring to be able to get this left side of the equal sign factored. First thing I want to look for is greatest common factor. I see there's a 2 that can factor out, leaving me r squared plus r minus 30 equals 0. All right, my leading coefficient here is just a 1, so I can write down my 2 parentheses. So what times what is r squared? R times r. What times what is negative 30? That adds to be positive 1, right? So we're doing 1 times 30, 2 times 15, 3 times 10, 5 times 6, and it seems like 5 and 6 going to be the winning combination here, right? Where I'm going to have my 5 as a negative, because negative 5 times 6 gives me the negative 30. Negative 5 plus 6 gives me the positive 1 in the middle. So r minus 5 and r plus 6. All right, so we're not done yet. Remember, we're using this factoring to help us solve it. So now I'm going to set each part equal to 0, right? Each factor. So I'll do 2 equals 0. Well, there's nothing to solve here, right? And that's just nonsense. That's not a true statement. So don't worry about that part. We're just focusing on the parts where we have r's to solve for, right? So we have r minus 5 equals 0 and r plus 6 equals 0. So let's add the 5 over. We get r equals positive 5. Subtract the 6 over, and we get r equals negative 6. Okay, now remember, we're talking about the number of rows and number of columns. It doesn't make sense to have a negative amount of rows. So we're going to call this an extraneous solution, and that's not going to be a good one. So we're going to use the other one. So r equals 5 would be our answer. So the number of rows, right, is 5. And then to find the number of columns, right, we need to use that 2r plus 2. So we'll replace the r with 5, because remember we just found that number of rows is 5, so we can put that in there. So 2 times 5 is 10, plus 2 is 12. So 5 rows, 12 columns. All right, and if I multiply 5 and 12 together, I get 60, which is what I wanted to end up with. So that is good there. Okay. All right, let's look at the other little story problem here too. All right, so the area of a square is 3 times its perimeter. Find the length of a side of the square. So whenever I'm trying to imagine in my mind what it is I'm trying to solve, I like to draw a picture of what I have. All right, so it says I'm talking about a square, and it's telling me how the area and the perimeter are related to each other. All right, so it's saying that the area, all right, is going to equal 3 times the perimeter. Okay, but let's think about how we're going to name this. Well, we're trying to find the length of each side. All right, so I'm going to call the length of the side, the square, S. I don't know how long it is, right? But I know that since it's a square, the length and the width are the same, right? And so when I find the area of that square, it's just S times S, which is S squared. Okay? And then the 3 times the perimeter, so I'm going to do 3, and then how do we find the perimeter? Well, we add all sides together, right? So S plus S plus S plus S. And then if I simplify this more, so S squared equals 3 times 4S, so S squared equals 12S. All right, so again, remember, I'm trying to solve for S. What is the length of that side? I have a quadratic, so I need to move everything over to one side, put the other side equals 0. So I'm going to subtract 12 over to the left side. So I'll have S squared minus 12S equals 0. And now let's go ahead and factor this. So S factors out as the greatest common factor, leaving S minus 12 equals 0. And then we need to set both parts equal to 0. So S equals 0 and S equals 12. Well, again, S equals 0. This isn't a negative number, but the length of the side has to have some length to it in order for it to be a square. So again, this S equals 0 is an extraneous solution, and we'll just go with S equals 12. And that's what I'm looking for. So the length of the side of the square is 12, right? If I do the area of that, that's the answer, but if we thought about this, right, just to check our answer, well, 12 times 12 is 144. And then if we did the perimeter of it, 12, 12, 12, 12, all right, so if we do, that's 12 times 4 is 48, but remember it said it was 3 times the perimeter, and 3 times 48 also gives me 144. So it's always a good idea to kind of go back and check, if you can on this. Make sure your answers make sense when you're dealing with story problems. If you come up with negative things and go, okay, that part can't work, I can only, use these positive values on there.